mode, whatever the value of register is there, it is treated as an address, and that address, whatever the data value is there, it is copied into the A register. Means what? After execution of this instruction, what is the value of A? A becomes 03. Okay, so see here, I will repeat once again. In the indirect addressing mode, or it is also called as a register indirect addressing mode, the address of operand, see here, the address of operand, operand कोण आहे 03, त्याचा ऍड्रेस काय आहे 05. So the address of operand is specified as the content of register. Is it okay? So this will be clearer with this example. Okay, so and symbol indicates that the addressing mode is indirect. So whenever you are going to use the word indirect addressing mode, you have to mention the specific word called as %. Okay, so whenever there is %, जर %% असेल तर आपल्याला काय समजणार आहे बघा, की या रजिस्टरनी जी व्हॅल्यू सांगितलेली आहे ती ऍड्रेस आहे आणि त्या ऍड्रेसला आपला डेटा आहे. जर तिथे %% वगैरे काहीच नसेल, सिंपल इन्स्ट्रक्शन असेल कुठली, मूव A, R1, तर याच्यावरून आपल्याला काय कळेल, R1 मधली जी काही व्हॅल्यू आहे किंवा डेटा आहे तो कुठे जायला पाहिजे, A मध्ये. पण जर %% आलं तर आपल्याला पहिली गोष्ट काय कळणार की हा इनडायरेक्ट ऍड्रेसिंग मोड आहे, म्हणजे काय R1 ची जी काही व्हॅल्यू आहे तो आपला डेटा नाहीये, तो काय ऍड्रेस आहे, आणि त्या ऍड्रेसला जी व्हॅल्यू असेल ती व्हॅल्यू कुठे केली जाईल, A मध्ये मूव केली जाईल. समजलं का? हॅलो, क्लिअर झालं का? हॅलो, इज इट क्लिअर टू ऑल? Shall I repeat once again? Give me response fast.
Yes, madam.
Is it clear or repeat once again?
Repeat.
Okay. So see here, the fourth addressing mode is a indirect addressing mode, or also called as a register indirect addressing mode. Okay. So see here, in such type of the addressing mode, first thing we have to use the % sign. Okay. Now, whatever the value stored by the register is taken as an address, and the data stored at that address is going to copied into the A register. Okay. Now tell me, what is the meaning of first register, or what is the output after the execution of first instruction? A becomes
05.
move A, R7 means what? Very good. Move A, R7 means what? Means what? Value of R7 is going to transfer at A location. What is the value of R7? Give me reply fast.
05.
05. So after execution of this instruction, A becomes 05. Very good. Now see here, same instruction but written in another way. Move A, @R7. What it means? Whatever the value of R7 is there, it is not a data, it is a address, and you have to store the value, means you have to take the value stored at that address. Now see, what is the value of R7? 05. So treat 05 as the address, and whatever the data stored at this address is going to transfer into A register. Now you tell me, what is the value of A after execution of this instruction? A becomes
03.
Very good. Is it clear to all? Is it okay?
Okay.
Is it okay? Is it okay? Hello.
Okay.
Now there is a one example for you. See. Now for example, at R6 I have stored the value. At R6 I have stored the value, for example 0A. It is the value. Otherwise take it value like this, 08. Okay. So 08 is a, at 08 you are having the data 05. Okay. Now first thing, by using immediate By using immediate addressing, what you have to do, you have to assign the value to R6 register. Okay. Now, second, use the register addressing. Okay, use the register addressing mode and assign the value to R6. Third, use direct addressing. Fourth, use indirect addressing. Now, you tell me one by one instructions for that. If I have told you that, what? No, here you can. Whatever the value of R6, you have to copy that value into R4 instruction, R4 register by using immediate addressing. How you can write that instruction? Eight five in the 8085 fifth mode is a implied. In the implied, whatever the value of accumulator, it is taken as a data. You need not to mention the data separately. Okay, but in the index addressing mode, this mode is used to access the data from the external memory. Okay, what we know about the microcontroller? In the microcontroller, we can use external data memory. Okay, so to access the value from that data memory, we need to use the index addressing mode. And how we can write this? See here, move a comma @a plus dptr. So whenever dptr is coming, what we come to know? It is dealing with the external memory. Why? Because dptr is the pointer which accesses the location from the external memory. Okay, so see here, what is the execution of indexed addressing mode? See here, value of dptr plus value of accumulator is going to added, and whatever that value is there, it is treated as an address. Why? It is an indirect, and at that address, whatever the data is there, it is going to move into the A register. So see here, with index addressing mode, the effective address of the operand is the sum. Okay, म्हणजे आता तुम्हाला ऍड्रेस मिळणार आहे. @ म्हणजे काय? जी काही व्हॅल्यू असेल तो ऍड्रेस असेल, त्या ऍड्रेसला तुम्हाला डेटा भेटेल. मग ऍड्रेस कसा मिळणार आहे? बाय ऍडिशन ऑफ अक्युमुलेटर व्हॅल्यू विथ डीपीटीआर व्हॅल्यू. ओके, सो डीपीटीआर ची व्हॅल्यू प्लस अक्युमुलेटर ची व्हॅल्यू करून जी, आता फॉर एक्झाम्पल डीपीटीआर कन्सिडर करा 0003 आहे, accumulator ची value consider करा for example 01 आहे. So what the value you will get combinedly 0004. So treat this 0004 as a address. का 004 address का? कारण की ampersand sign आहे. ampersand sign तुम्हाला काय सांगितलं? याच्या माझ्या पुढे जर काय असेल तर तुम्हाला ऍड्रेस देईल. मग ampersand च्या पुढे काय आहे? this sum आहे. So this sum काय दिली तुम्हाला? ऍड्रेस दिला. So 0004 या लोकेशनला जो ऍड्रेस आहे तो ऍड्रेस, सॉरी, या लोकेशनला जी व्हॅल्यू आहे ती व्हॅल्यू काय करा? ए मध्ये मूव करा. Okay, so once again read this. With index addressing mode, the effective address of operand is sum of the base register and the offset register. The base register can be either data pointer or program counter, while the offset register is always accumulator. In index addressing mode, only MOVC and jump instruction can be used, because in this such type of instruction you have to going to change the execution of the sequence. Okay, so index addressing mode is useful when retrieving data from the lookup tables. Now lookup table is the concept which we are going to deal with at the time of interfacing of the keyboard. Okay, so at that time I will again refresh this concept of lookup tables. So here the address of operand is the sum of the content of dptr and accumulator.